going to be reviewing transformations today. I did promise you the questions to your quiz, so put down your calculators. Eyes up here, please. Yesterday we talked about the range being up and down the elevator. You're checking to see if there's action on the floors. You're going to go up the elevator, check each floor, then you're going to go on the main floor, see if there's any action. Move it. Then you're also going to go down the basement and see if there's anything in the parking structure. You're always just going to check see if there's any action. Isaiah, I'm waiting for you. Still waiting. So here's our function. F of x is equal to negative 1/3 to the x minus 5. So we're going to plug in our Fab 5. Nathan, what's our Fab 5? Beautiful. Negative 2, 0, negative 1, 0, 1, and 2. Shh. So we're going to plug in these 5 numbers. Hannah, what'd you get when you plugged in negative 2? Negative what? Opa. So ready? 1/3 to the negative 2. Put that in your calculator for me. Renzo, can we see if everybody knows how to put a negative 2 in the exponent, please? 1/3 to the negative 2. Make sure you put that in the calculator. Nathan, do you see why it's so important to have your calculator? Do you know off the top of your head what 1/3 to the negative 2 is? Nathan, answer me, please. Do you have your calculator at home? Can you please bring it every day? Thank you. Moses, can you show Nathan how to put it in the calculator so when he goes home he knows how to do it? No, it's 1/3 to the negative 2, then make it negative. So that becomes negative 9, now minus 5. Don't forget about the minus 5 right here. Alright, so the first one you get is negative 14. If you don't have that, you should put it down. Negative 14. Ben, what'd you get for negative 1? No, you forgot to put that negative right there. You got 9, but then you forgot to make it negative. So 1/3 to the negative 2 is 9, and then make that negative. That's negative 9. Negative 9 minus 5 is negative 14. All the side chit chat needs to stop. Thank you so much. Ben? Ready? What's 1/3 to the negative 1? Yes, now make it negative. Good, negative 3. What's negative 3 minus 5? Thank you. Everybody put a negative right there. Jameson, what'd you get for 0?
Negative 6.
Thank you. Good job. Annette, what'd you get for 1? Good job. Yes? You can use your scientific calculators. Good question. Yes, you can. No graphing calculators. And then the last one I know is a little hard. I'll give it to you is negative 46 over 9. So that question is, what is the range? So what I have to do is go ahead and plot the points. And then I just have to go up and down the elevator, guys, and decide what the range is. Is there action on the basement negative 8? So if I go down the elevator and walk down the hallways, do I have anybody in the hallways here? Yes. How about negative 10? How about negative 10? Do I have anybody on the negative 10th floor? There's action right there. How about the negative 12? How about negative 14? So there's action happening all, how about over here on the first floor? Is there anything happening on the first floor? Not so far. I don't see anything happening. In fact, there's no action happening above the 0 line. Everybody see that? So how do you tell people, look, all the action is above the 0? How do you tell people all the action is below the 0? Camden? So y has to be negative, but how do you tell people it has to be negative? What number tells you that it has to be below what number to make it negative? Very good. Y has to be less than 0. Good job. All right. Mikhail walked around and stamped last night's homework, so we should be feeling a little bit better about transformations. Everybody needs to take out their calculators, please, and I want you to tell me what your calculator says. What is 4 to the 0? Don't yell it out. Put it on your calculator. What's 4 to the 0? I said don't yell it out, please. It's okay. Jacob does what he wants to do anyway. Hi, Jacob. Isaiah, what's 4 to the 0? 1. Moses, can you tell me what 5 to the 0 is? 1. Good. Kira, what is negative 7 to the 0? Does your calculator not work? Maybe Lorenzo can help you. Isaiah, what's 243 to the 0? Positive, don't matter. What's 243 to the 0?
I mean 1.
It is 1. So anything to the 1 is going to give me, anything to the 0 is 1. This is section 5.5, reviewing transformations. Tonight's homework is worksheet number 57. I'm going to have Mikhail pass it out to you in a second. I'm sorry, honey? Well, this one's kind of hard, so let's make sure, okay? All right, so make yourself a little cloud, please. And reminder, Jameson, remember we just said, what is 4 to the 0? It's just 1. Jose, what's 5 to the 0? Just 1. Jacob, what's 243 to the 0? 1. What's negative 7 to the 0? Dillinger? 1. So what's x to the 0? Jeremiah? 1. Anything to the 0 power, and this is why I asked you to show me your highlighters. I need you to highlight those zeros. Anything to the 0 power is 1. Yes, sir.
If it's a negative, it's negative.
Yeah, but that's if the negative's outside. Good point. Good point, Isaiah. That's if the negative is outside. All right, so make yourself another cloud, please. And as a reminder, if I have 5 squared here, and then I have a 5x here, and I gave you $1 million to tell me what that x is. If the 5s are the same here, if the bases are the same, I bet you could tell me what the x is. What does the x have to be if there's an equal sign right here? Jose? What do you think, babe? Sure, babe. See how the 5s are the same? And I want to know what x is. So if 5 squared is what says on the left-hand side, then the right-hand side has to say the same thing. So what does x have to be? Also squared. So x has to be 2. So what I want you to do is highlight these exponents because the bases are already the same. And that's what we're going to be doing today. Nathan, write this down, please. I'm going to do the odds with you for tonight's homework. Mikayo, I need you to pass out the worksheet, honey. And then you guys are going to do the evens. Throw it up here. We'll just put a 0 for now. I left it over there. So here we go. Number 1. If I have 4 to the 2x plus 3 equaling, whoa, I should say equal, I'm so sorry, equals 1. Nathan, please write this down. Sorry, no, this is an equal sign. That's my bad. Alright, I want these bases to be the same like I did here. Because if the bases are the same, then I can just pay attention to the exponents. Well, I know how to write 1 with a base of 4. 4 to the what is 1 again? Look at the other cloud. 4 to the what is 1? 0. So set it equal to that. So 4 to the 2x plus 1. Jason, I need you to catch up. You're going to be really, really, really lost. Let's go, babe. And this says 4 to the 2x plus 1. This says 4 to the 0. Does everybody see how the two bases are the same? Well, if the two bases are the same, then the exponents have to be the same. Write that down, please. If the bases are the same, then the exponents have to be the same. So what I'm going to do before I even get started, and we will not stamp you if I do not have these highlighted, you need to highlight the exponents after you've made the bases the same. So now all we have to do is solve by setting the bases equal to each other. I'm sorry, the exponents equal to each other. So I'm just going to take this 2x plus 1 and set it equal to 0. Because Jose told us since the bases are the same, that means the exponents are the same. So now you're going to solve for x. So you're going to subtract 1 on both sides. So 2x equals negative 1. Divide by 2. X equals negative 1/2. Oh, thank you. The more we do of these, the better you'll feel. Let's try number 3. I'd have 3 to the 1 minus 2x equals 243. Uh-oh, our bases are not the same, but I can make it the same. On my calculator, 3 to the what gives me 243? Don't yell it out. Is it 3 squared? Is it 3 to the 3rd? Is it 3 to the 4th? If I have to say your name again, we're going to have issues. I need eyes on me. Yes. 3 to the something gives me 243. Let me know when you find it. Don't yell it out. Jacob? 3 to the 5. Very good. So 3 to the 5th power, so put a 5 here, equals 3 to the 1 minus 2x. Laura, are the bases the same? Laura? And that means the exponents are the same. Good. So let's focus on the exponents. Now I'm going to set them equal to each other. 1 minus 2x equals 5. Subtract 1 on both sides. I get negative 2x equals 4. Divide by negative 2. X equals negative 2. Let's try number 5. We have another one with a 1 here. I have 4 to the 3x minus 2 equaling 1. Uh-oh, my bases are not the same, but I can make it the same. How can I make this 1, Jaden? How can I make this with a 4 base? 4 to the what gives you 1? Good job. So I'm going to put this as 4 to the 0, and this is 4 to the 3x minus 2. My bases are the same, so I'm now going to focus on my exponents. I'm going to set these equal to each other, and I have 3x minus 2 equaling 0. I'm going to add 2 to both sides. So I get 3x equals 2. Divide both sides by 3. I get x equals 2/3. Let's try number 7. Kyle, can you walk around it? See if anybody needs me? If I'm going too fast. Here we go. 6 to the negative 2a equals 6 to the 2 minus 3a. Yay! Why am I happy? What do I notice about the bases? They're the same. So all I need to do is focus on the exponents. So I'm going to go ahead and highlight the exponents. And now the exponents have to be the same. So I'm going to set these guys equal to each other. So I have negative 2a equals 2 minus 3a. I'm going to add 3a to both sides. Negative team has 2 points, positive team has 3. So that means a equals 2. Questions so far? The trick is getting the bases to be the same. That's it. Yeah, baby, go. The bases are the same, Mama. Right? Since the bases are the same, you want to solve for the exponents. Let's try number 9. Let's see if we remember our exponent properties. 6 to the 3m times 6 to the negative m equals 6 to the negative 2m. Emilio, do you need to step out? So as a reminder with exponents, let's make our little cloud on the side to make sure we can remember. If I have a to the 4th times a to the 3rd, all I need to do is add the exponents and I get a to the 7th. I have to add the exponents. Why, you ask? Because this is a to the 4th, that's 1, 2, 3, 4. This is a cubed, that's 1, 2, 3. That's 1, 2, 3, 4, 5, 6, 7. That's a to the 7th. Lorenzo, apparently Isaiah needs you to stand right behind them in order to do what he needs to do. Can you do that for me? Sorry to waste your time. So again, when you multiply exponents, you're going to add the actual exponents. So here I have a multiplication sign. So I need to add these two first. Jose, don't let me lose you. So I have 3 m's and a negative m. So 4 plus 3 is 7. 3m plus a negative m. That's how many m's? 2 m's. Good job. Now my bases are the same. I'm going to highlight. Set my exponents equal to each other. Jason, don't let me lose you. Come on, babe. I got 2m equals negative 2m. I'm going to add 2m to both sides. I get 4m's equals 0. Divide both sides by 4. M equals 0. You can print it from your desk. Just save it. Questions on number 9? Jeremiah, how you feeling about this stuff? A-okay? Let's do one more and then I'll give you a doyo. Number 11. Savannah, how we doing, girl? So let's say we have 10 to the negative 3x times 10 to the x equals 1 over 10. I'm going to add these exponents. Camden, what is that? What is 10 to the negative 3x times 10 to the x? Negative how many? Very good. Negative 2x. Uh-oh. I need the same base for a handful of candy. Raise your hand if you can tell me. Yesterday I said it twice. Lorenzo said it twice the day before that. We did it last week. How can I write 1/10 with a base of 10? 10 to the what gives me 1/10? Do not yell it out. I see one hand. 2. Go back in your notes. Good. It is yesterday's notes. We have it in there. We did it all day yesterday. 10 to the something gives you 1/10. 3 hands. 4. Look back at yesterday's notes. Nathan, it's in your notes from yesterday. Steven, what is it? Yeah, very good. When you have a negative exponent, remember it becomes a fraction. Good job, babe. Lorenzo, can we get him his candy? Alright, now the bases are the same, so what am I going to focus on? Talk to me, guys. What am I going to focus on? The bases are the same, so now what are you going to focus on? Savannah, ready? The bases are the same, so now I'm going to focus on the... Thank you. Thank you, Jaden. I'm going to focus on the exponents. Guerrero, tell me what to do from here. We just did 6 examples. If you were paying attention, you should be able to tell me something. So help me out, babe. Good job. See, you're looking back at the other questions. That's what I want you to do. Now that you have that the bases are the same, what do you do? What do you want me to do? What do you want me to write? Go back to the previous 5, 6 examples that we did. What did we do every single time? Now that they're highlighted, now what? Okay, somebody in your group can help you. What do you want me to write, babe? Almost. So negative 2x equals negative 1. Divide both sides by negative 2. And you get x equals 1/2. Alright, here's your doyo. Number 2. 5 to the 3 minus 2x equals 5 to the negative x. Do this by yourself. Here come the boys if you need help.